Hey guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I'd greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow guys, all that aside, let's get on with the show. Here we go. It's your time, man. So this is one of the last few that got built by Chris over at Ass Kicker. And then it ended up going to some other person that did some very funky stuff to it. We're calling this the squirrel box because of this stuff here. This thing's pretty chewed up on the inside. A lot of funky stuff going on back here too. We're going to take all the little bits and pieces of this out. We're going to rebuild it and put it back together correctly. Like this is not nearly adequate enough. Yeah. Sorry. This isn't nearly adequate enough for the final output capacitors, so we're going to strip this down. We're going to rebuild it correctly, and then we're going to put it all the way back together. And so yeah, let's get started. First things first, we got to clean all this up. We're going to clean all this up. We set the voltages on the power supply so they're actually all trimmed the same. Got to replace this horse shit and replace. The wire's not even soldered in there. It's just held in by tension. Okay, give me a few minutes. We'll be back. Just want to cover a couple things real quick. So that's a 6F, that's a 6F, that's a 6F, and that's a 6F. Now, this capacitor has been changed, obviously, right? So that leads me to wonder what else is going on. Now, as your eyes wander around this very simplistic palette, we notice that we're missing a couple parts, like the 330 puff capacitors on the inputs, right? Then we come around here and we look at the actual input tuning capacitor. That's a 150, which is catastrophically low. The turn radius on the input transformers is wrong. There's too many turns. The output turns have got too many turns in them. These are out of a Texas Star. These are reused, but these are 1000 puff metal mylars, or metal clads, but this one is not soldered down. And so then we start looking at the fine details, like the size of the 10 ohm resistors here. See how these are all the same? But then we've got the Radio Shack watt meter, or the Radio Shack wattage resistor. So then we go and we look, this is the stock 2 watt resistor on the input. Then we've got this aftermarket resistor that obviously has been cut, as we can see here. And this has been cut and this has been grafted together, as we can see here. It wouldn't surprise me that this transistor is junk. And I don't know what kind of 2 watt Radio Shack soldering iron pulled all these out, but all these transistors have been out. Because I know Chris and he doesn't solder like this. The rest of this stuff is just all dressing, window dressing. I have a feeling that this power supply or this power supply, one of the two, has gone bad at some point or other, because these aren't even the same manufacturer. And a pretty good clue to that is that the aluminum colors, they're not the same. So this gentleman also wants to do the preamp delete on this, so we're going to pull this circuit out and remove it. Wow, this is literally the most basic box there is. So I think what I'm going to do is we're going to pull the pills out. We're going to test them. I'm pretty sure this one's toast. And this is somebody trying to cover that up here. And then this would be an indicator that pretty sure that this output capacitor is what's failed, which started this whole chain reaction. And then the rest of this is somebody trying to figure out how to fix this. So, but first things first, we've got to repair this, make this correct. This isn't the right wattage of on-off switch, not the right amperage. Repair our ground lead, which this doesn't go here. This goes to the case. The details. Okay. I was sitting here looking at this, and I'm like, why are we missing the input capacitors? And then I seen that 10 ohm resistor, and I went, okay. So, all right, let's rip it apart. Okay, so what we've done is we've disconnected them from the board, and now they're running independently of each other. The fact that both LEDs come on is a pretty good indicator that both supplies are working. So now what we're going to do is we're going to measure each one of the power supply's outputs. So let me probe in on this one, and that's at 15.5. So we got to check all these things because, well, you don't know whose fingers have been in the pie here. That's at 15.5 also. Okay, so we got that going on for us. Let me let's go ahead and let's clean up this 110 volt power lead system here, and we can come over here and we can clean all this mess up too. All right. Okay, the more and more I look at this, the more I realize this is not right. So right now the way this is set up is the brown wire is your hot, okay, and your blue wire is your return, okay, and your green wire is your ground. This is straight from Home Depot. 110 outlet. So what we're doing is we're switching on the return, which is not necessarily bad. It's not necessarily electrically correct either. The other thing is I've noticed is that what happens if the guy wants to run this on 220 for some reason in the future? How does he get access to the switches that are the 110 220 switches on the top? That's right. All of these have got to come out and they got flipped around. The other thing that we got to look at is that the hot, look, he's got ground. It's not going to the case. It's actually being floated through the cabinet. So there's absolutely no ground return for the electrical system anywhere in this case. There is a little tiny disc capacitor that comes off of this connection up here that goes to ground, but that doesn't electrically do us hardly any good. The hot lead and then our return are both tied to the same power supply. So that means this power supply is going to get more current than this power supply. So this is drinking from the well after this one, which means not equal load sharing. So which one do you think is going to take more of the load? Just saying. That's probably why this one's been replaced. Okay, I got to pull these out, flip them around, re-drill some holes, and then I'm going to actually space these out a little bit. Now this is technically enough gap, but you'd want to have a little bit more space in here, that way that this power supply could cool itself. So the guy sent this thing up to me to completely debug it. Well, that's what we're going to do. Test. Cool. One's got a gain of 34. Gain of 30. For a cheap basic transistor checker in a nice package, and it checks MOSFETs and all kinds of ICs and everything, this is the best product in my opinion on the market. For a little handheld tester, that is. So it's got a gain of 27. That was the one with the bad resistor, the funky resistor on it. Okay. Nope, come here. Gain of 32. Oh, that's a good deal. All four of them transistors are good. you gotta do is go through and clean up all the tabs and make sure they're all nice and straight. Clean any excess flux or any excess solder off all the tab legs, like this stuff here. Straighten this out. Let's see, excess solder. Get this all cleaned up and we'll put these back in the amp. It's been a long day. I got called away to the full-time job today. So I got stopped on this thing halfway through and I thought, well, I'll come back and finish it before I go to bed. Well guys, I got a little bit carried away with the artistic license on this side of this thing. It started with me wanting to flip the power supplies around, right? And what I was going to initially do is just rotate them so we could have the switches, and I was going to leave the positive rails this direction. But then you find yourself doing things out of habit. Like I use these high-end switch mode supplies, and sometimes you put them too close to the relay section, you'll hear some switch noise. So I figured out that if you just simply turn them around on the cabinet and then feed your power wires the other way, the problem goes away. So I went ahead and I flipped these around, and then I flipped them around the other direction. And then I came in here and I got rid of all the chewed up squirrel mess, and I replaced it with all brand new wire. Now this wire is a little overkill. This is way bigger than necessary. It's what I've got laying here. I've got to get with my wire guy in the next couple days, but each one of these has the same length power wire on the hot and the return leads. The return is now isolated. The ground is independent from the source point, and it goes back to the cabinet. Now I got to looking at the specs on the switch. This is actually a 15 amp switch, so we were able to reuse that. Now as soon as I started doing this, the power leads, that's when we went off the rails a little bit. I went ahead and I blocked off the back vents on the back of the cabinet. I also blocked off the side of the board. So now it's forced air laminate flow straight through the cabinet. It's all blocked off nice and clean. So all the cooling air has to come down, wrap across the components, and exhaust across the heatsink is actually going to do us some good. So first thing I did is I stripped off all the components that I wasn't a big fan of. And I washed the board. That's what all the white mark is. Now this won't be like this when I send it out of here. The white marks that are on here. What this is from is a little residue of the clear. When they first punch the boards out for all of us to use, they spray a little bit of clear on them to keep them from corroding. So when I came in here and I gave the thing a bath, which it horribly desperately needed, right after I pulled the transistors out and checked them, you get a little bit of residue. Just a little bit of residue that's left over on the board. So once I go and run this thing, which I'm going to do here in a minute, I just wanted to show it to you before I started testing it. We're going to probably end up changing the input tune. Wouldn't surprise me if I have to end up changing the input combiner and the turns in the input transformer a little bit. But all the pills checked out good. I went and I resoldered everything. Replaced our 10 ohm resistor down here that was burnt. Now, I don't know how well this is going to tune having the induction this long, because it's really designed to, the induction circuit's only really designed to be about that long. But we're going to give it a whack. So I'm not quite done yet. We're getting really close. Way cleaner. A whole lot more organized. We've got actual eyelets on everything. Everything's twisted and braided, and of course it's got heat shrink on everything. The way it should be done. I don't know if Stick did this one or not. I've worked on several of his amps at this point. And I would definitely say no. There was some Stick feeling in here, as in like there was a little bit of influence back in the day, but I think the guy that had it before me that was supposedly doing something to it is the one that did all the butchery. But we fixed all that. I did the preamp delete on it. Oh yeah, I've got to add a little piece of wire here to short across the terminals for the receive. Did the preamp delete on it. Added an output tuning capacitor. Of course, I actually put a ground strap in the amplifier, and plugged up the hole and gave him the mounting hardware for it. So on that note, I think I'm ready to go ahead and start doing the testing. Got a little piece of wire here for the receive, so it's completed, the circuit's complete. We'll measure that with the KC901 network analyzer, and then we're going to give it a test drive. Now, I did do one other thing. I can't stand that galvanized look. To me, that it just looks not professional. So I pulled the galvanizing out. It's over in paint right now. It's drying at the moment, so when we come back, probably the galvanized plate will be in there, and we'll be testing this thing. So on that note, on to the next step. Well, here we are, we're all done. Input tune's now been redone. Output tune is fixed. And the only problem we had is this power supply had to come back out because the fan on the power supply was going bad. So I ripped this one apart and I changed the fan in it real quick and put it back together and put it back in. So, on that note, we're all done. Lid covers are now painted black. Things all cleaned up. Now, what I want to point out is this switch now, instead of doing preamp, it does the operate. So you got standby and operate. Okay. So here's power. Here's your operate, which is shown by this little green LED down here. So let me throw the tin on it. A completely different amplifier on the inside. And this thing's working. So give me just a second. Okay, so there we go. Finally the test portion. 1000 watt slug and peak, 1000 watt slug and average, 5 watt slug and reverse back from the bird, 10,000 watt dummy load. 2950 with the 5 watt slug between the 2950 and the ass kicker straight 4-pill. Now I do want to cover something. 4 of the screws that were sent with this thing were really aggressive thread. They were the wrong thread type, and they're down there in the corner of this bag. So I don't have any black 632 screws, so I just went ahead and I put silver in their place. I hope you don't mind, but that's what you're going to get. So, on that note, here's what I'm putting into it for drive. Hello. Here's what we're getting for our input reflect. As far as pass through, nothing. Turn the amp on. We're going to go to operate. Okay. Input tune. Put this thing down in standby. We're going to turn on our 2-pill. So what we're going to put into it for drive. About 200 watts input drive. Clicking into operate. PVI got down. PVI got down. Now that's cute and all, but that's the anemic bench radio, right? So I reach up there, we're going to turn on the D-rail radio. Take that out of line. Oh, BBI, what kind of coax is that? This 316 coax, by the way. Dual shield. This little tiny stuff. Alright, let's make sure I grab the right microphone. Hello. So, with the right radio attached, this thing's moving some air through here, by the way. Blocking these off and making it so all the air's got to go across that heatsink. Way better. So with the right kind of radio, we're seeing about 550 to 600 peak on the average meter. We're seeing well north of 1,000 watts. I mean, it's just laying the needle on the stop, so it's about 1,200 watts peak coming out of this little 4-pill. Brother, what you sent me was a chewed up pile of shit. Like literally a squirrel had chewed on it. So we're going to call this the squirrel box. But it ain't that way anymore. It's a work of art on the inside. It's as cleaned up as I can get it for the amount of money that we wanted to spend. That's all we got. I spent a couple days on this. I've had a lot of stuff going on in the background that I haven't been able to stay focused on this. This is literally like a one-day project, and it has taken me 3 days to do it. Being called away for a whole day at my job really kind of screwed me up. But at the end of the day, we're done. And that's what matters. The amp's done right. It sure looks a whole hell of a lot better on the inside. And it's putting out the watts. So on that note, I gotta go. The Skull 850 watt radio is up next. I'll probably shoot that video this evening and it'll be out tomorrow. It's a 955 that the cases have been hydro dipped, and it's got a custom 4-pill strap-on amplifier on the bottom of it. Does about 850 watts. So on that note, guys, I've got to go. A whole lot more stuff to do. I appreciate you all tuning in. If you haven't taken a moment, please click subscribe. If you've enjoyed what you've seen, that is. If not, go on to the next video. Gentlemen, I appreciate your all support, and I thank you all for your patience and all these wonderful projects to work on. I'll see you guys in the next video. Bump, bump from the biggest mud duck in Idaho. I'll see you. Bye-bye.